Good morning. We are starting my absolute favorite unit right now, and this is called Trig. So I'm sure some of you have heard about Trig and you're like, oh no. But we are going to start slow and steady with Trig, and you are going to love it. So we're going to start with just identifying the trigonometric ratio. So most of the time you're just going to abbreviate this and just say Trig. But if we're going to be cool and fancy, we're going to call them the trigonometric ratios. So before we start that, what I want to do is identify the sides that are opposite, adjacent, and the hypotenuse based on the angle. So when I look at these examples, so when I start here and I look from angle C, I'm going to put a little arc in the corner so that I know where I'm looking from. Oftentimes in trig, you're going to see this labeled as a theta, so a circle with a line through it. I need to figure out what's directly opposite, what's adjacent, and what's the hypotenuse. So let's start with something easy. Where is the hypotenuse here? Well, I know the hypotenuse is always directly across from the 90-degree angle. So this would be my hypotenuse. So I could go to my hypotenuse section and say this line A to C is my hypotenuse. Now what's going to be directly opposite from this theta? So from this angle C, directly opposite, I'm going to draw a line all the way across. This is my opposite line, also known as AB. And then whatever is left over has to be the adjacent side. So notice the adjacent side, or BC, is touching this angle C. It's part of that angle. So if I cover this up, so I'm putting my hand right now on C, the side that's directly opposite of this is the only side my hand is not touching. So notice if you put your hand on angle C, the side opposite is the one your hand is not touching. So that can kind of help you differentiate between opposite and adjacent. So look over here, maybe pause your video. See if you can figure this out from angle F. Can I determine who is opposite, adjacent, and the hypotenuse? So go ahead and pause, try that now. So the hypotenuse, let's start here, has to be across from my 90-degree angle. So this line, E to F, is actually my hypotenuse. Now let's figure out what's directly opposite. So directly opposite from F is line E to D. So I'm going to put an O. And then whatever's left over, EF, has to be my adjacent. Notice EF has the point that I'm starting in. That has to be the adjacent side. And notice the only side opposite does not have this letter on there. So that's how I know it's directly opposite. I cover up F. Is someone directly across. So let's kind of dive into these trig ratios. So trigonometric ratios are in only right triangles. This is only true if I have a triangle and a 90-degree angle in the corner. It will never work for any other triangle. When that happens, ooh, sorry, my board's squeaking. When that happens, I have three ratios. They are sine, and you see it as SIN. In your calculator, you will not say sin. It is sine, okay? We're going to sound like we're mathematicians. This is called sine, cosine, or COS, and tangent, or tan. These are all functions in your calculator. So whether you knew what they do now or not, we're going to learn that tomorrow. So let's start at the beginning. What in the world does sine mean? So anytime I see sine, or SIN, I'm going to know that this is the opposite side over the hypotenuse. So I'm going to think about what's opposite and what's the hypotenuse. So when I look at this first example, it's asking me what is the, what is the sine of A? So now I know, because this says A, I know I'm looking from angle A. So I'm going to put my little theta in A. And I'm going to label this. What's this? What's the hypotenuse directly across from C? This is my H. What's my opposite directly across from my theta, or O? And then the other side left over has to be A. Well, in sine, I don't care about A. It doesn't matter to me. What I know sine of A has to be, it has to be little a over C, or opposite over hypotenuse. You could also write this out as the line BC over the line AB. So let's look at the next example. I wrote this in a different color for a specific reason. What if I was looking from sine of B? Is this going to be the same thing? The answer is no. From this angle B, this theta, My hypotenuse still doesn't change. It's still across from the 90. However, the side opposite does change. That means this would be adjacent. So this, in this situation, now I don't care about this little a side. What I care about is little b over my hypotenuse. Also, the line AC over AB. So this trig ratio will always apply in a right triangle. So let's look at our next example. We've got cosine. Now cosine is different from sine because instead of talking about opposite over hypotenuse, now I'm talking about the ratio of adjacent over hypotenuse. So let's look, where am I looking from? So for cosine of A, I'm going to put my theta at A. I'm going to label this opposite adjacent hypotenuse. So across from my 90 is my hypotenuse, across from my theta is my opposite, whatever's left over is my adjacent. So if I were to look at the ratio of sides adjacent over hypotenuse, now I don't care about this O, I'm going to put little b over c. Or this line CA over AB. I'm going to do the same exact thing if I were talking about cosine of B. So again, just like sine of A and sine of B were not the same thing, cosine of A and cosine of B are not going to be the same thing. So this is going to be my new theta. Again, my hypotenuse stays the same. However, this side becomes opposite, this side becomes my adjacent. Now I don't care about the opposite side because I'm talking about adjacent over hypotenuse. So this becomes little a over my hypotenuse. So adjacent over the hypotenuse. So what I'm looking at are my trig ratios. I don't think I wrote, that line segment. So all I'm doing is looking at a ratio of sides. So last but not least, I've got tangent. So just like sine was opposite over adjacent, opposite over hypotenuse, cosine was adjacent over hypotenuse, tangent is opposite over adjacent. So I'm going to do the same exact thing. So this is my ratio I care about now. The opposite side is going over the adjacent side. So if I were looking at tangent of A, so I'm going to label A with my theta. I'm going to say, well, this is my hypotenuse, this is my opposite side, this is my adjacent side. Opposite directly across from theta. So if I want opposite, I'm going to put A. If I want adjacent, I'm going to put over B. So this becomes little a over little b. And if I were looking at tangent of B, just like I were looking at the other, I'm talking about from this angle B, so theta of B, this is going to be opposite, this is still my hypotenuse, this will be adjacent. So it's almost exactly the flip. All that it is B over A. So what you're going to see a lot is this phrase, SOHCAHTOA. So what SO stands for is sine is opposite over hypotenuse. Whoops, I'm spelling that twice. P-O-T-E-N-U-S-E. So opposite over hypotenuse. Ca is cosine, which is adjacent over hypotenuse, and tangent is opposite over adjacent. So this is your mnemonic device in order to remember what ratios apply to what trig function. So, whoops, I'm giving you the answers. So when I look at this example, it says write the ratios for sine of D, cosine of D, and tangent of D. Hopefully what you are going to notice is that D is the vertex. That's the angle in which I'm looking from. I don't get to choose, they're going to tell me. So if D is going to be my theta, I'm going to label this, well, across from the 90 is my hypotenuse, across from my theta is my opposite side, and then whatever's left over has to be my adjacent. So if I'm going to go through and call this sine of D, I'm going to say sine, so, SOHCAHTOA. Sine is opposite over hypotenuse, so 4 over 5. Cosine is A over H, or adjacent over hypotenuse, so cosine of D is going to be 3 over 5. And then last but not least, tangent of D is going to be opposite over adjacent, or 4 over 3. So hopefully now you're feeling confident. I want you to pause the video, maybe try the next problem all on your own. Hopefully what you've noticed now is that I'm talking about sine of D, cosine of D, tangent of D. I'm looking from this vantage point of D. So I'm going to put my theta here. Whoops. I'm going to label this H. Directly opposite is O, and then this has to be A. So sine, so opposite over hypotenuse, opposite side 8, hypotenuse over 17. Co, adjacent over hypotenuse for cosine, so 15 over 17. And then TOA, 8 over 15, or opposite over adjacent. So what I want you to do now is I want you to flip over and practice. Can you tell me what trig ratio, what just the ratio is? What's the ratio of the numbers? If you have any questions, please raise your hand and I would love to answer them.